Hello, in today's video we're going to be continuing our discussion on section 10.8, which is on systems of nonlinear equations. To solve systems of equations, we have three methods, whether they are linear or nonlinear. The first is graphing. The second is substitution. Our first video of section 10.8 was on substitution, and the third, as with linear equations, is elimination. I'd like to take a look at this nonlinear system of equations, and I would like to go about it by solving by graphing. So this first equation is a circle. It is centered at the origin because my x squared and my y squared have no horizontal or vertical shifts. And then my radius is going to be the square root of 49, which means that my radius is 7. So I have a center at the origin and the radius is 7, so I can go 7 in each of the left, right, up, down directions, and then I will do my best to sketch a circle through those 4 points. Now the second graph is going to be that of a parabola. Here my vertex is going to be at the coordinate 0 for x and 2 for y, so my vertex is here, and then my points, if you're familiar with that of a quadratic, will be left 1, up 1 from the vertex, 2, 4 from the vertex, 3, 9 from the vertex, and it is symmetric, so the same on the right-hand side. And then sketching our graph, we have our system of equations. And our goal is to use this graph to solve the system. In other words, we are looking for the points of intersection. So I see a point of intersection here and here. We want the exact coordinates of those 2 points. Well, if I'm looking for exact coordinates, that's going to be fairly difficult because these are not on what we call lattice points. They are in the middle of those corners. So this might be something around maybe 2.3 and a little bit less than 7, so 2.3 and maybe 6.8 or so. And then on the left-hand side, it does look like it should be about symmetric, so I'm going to go ahead and say that this is approximately negative 2.3 and still about 6.8 or almost 7 for my y value. So I was able to estimate a solution, but graphing is not clearly going to give us the most accurate solution, especially if you have a hard time, as I do, with sketching those graphs accurately. So we're going to go ahead and approach this by using substitution, and I'm going to show you 2 different methods to use substitution. So the first is to say that I know what y equals, so I'm going to take this value of y and replace it for y in my other equation. So in my first equation, I've got x squared plus y squared is equal to 49, and that y is going to be replaced by x squared plus 2. I can then simplify that x squared plus 2 all squared by multiplying, and I will get x to the 4th plus 4x to the 2nd plus 4, and that's going to be equal to 49. Then I combine like terms, so x to the 4th plus 5x squared plus 4 is equal to 49. And then since we are going to need to factor, I'm going to subtract my 49 from both sides so that I have 0 on one side, and I get minus 45 is equal to 0. Now this does have the form of a quadratic, so I'm going to go ahead and let a be equal to x squared, and that allows me to rewrite this as a squared plus 5a minus 45 is equal to 0. And then once I solve for a, I can more easily solve for x squared. So I'll use my quadratic formula. In this case, a equals negative b plus or minus the square root of 5 squared is 25 minus 4 times negative 45 times 1, all over 2 times 1, which is just 2, and this simplifies down to negative 5 plus or minus the square root of 205 all over 2. Which means that when I go ahead and look at x squared, so x squared is either the positive negative 5 plus the square root of 205 over 2, or x squared is negative 5 minus square root of 205 all over 2. Now unfortunately, x squared must be positive. If we're squaring a value, we must have a positive solution. So the second solution is going to give us a problem. X squared cannot be negative. That's not possible. So the second solution is a problem, so I'm going to go ahead and ignore it. It's what we call extraneous, meaning we were able to get there, but it actually doesn't make any sense. So then I have x could either be the positive square root or the negative square root of negative 5 plus the square root of 205 all over 2. When we go back and plug that value in then, we can find our values for y. So y equals x squared plus 2. So that's the square root of negative 5 plus square root of 205 all over 2. Square rooting and squaring are inverses, so this just becomes negative 5 plus square root of 205 over 2. And then I can combine my like terms here. If I add these two fractions together, I get negative 1 plus square root of 205 over 2. And similarly, if I have a negative here, so if I have let me go ahead and write this out, y equals the negative square root of negative 5 plus square root of 205 all over 2 squared. Since I'm squaring that negative, this is actually going to simplify down. Y equals negative 1 plus square root of 205, just like we had in our previous step. The negative squared gives us positive square root, which is exactly what we had in our first step. So then whether we plug in a negative or a positive value of x, we get that same y value. So our two solutions are positive square root of negative 5 plus rad 205 over 2. And then my y value is negative 1 plus square root 205 over 2. Or I can have a negative square root of negative 5 plus rad 205 over 2. And I still have that same y value of negative 1 plus square root of 205 over 2. So this is option 1. Option 2 I'm going to show you because it is a little bit unique, but it may be a more friendly approach to you depending on how you see things. So we are using substitution. What I'm going to do is actually subtract 2 from both sides here, and I am going to substitute my entire x squared. So now that I know what x squared is, I can replace it for x squared in my first equation. So here I've got x squared plus y squared is equal to 49. Y minus 2 is my x squared, and this is something that I can factor and solve. So y squared plus y minus 2 equals 49. I go ahead and subtract that 49 over, and we can solve. Now the only difference here is that you will actually be solving for y first instead of x, but either way it's just a second approach to solving this system of equations. Now option 3. We talked about graphing, we talked about substitution, and now we're going to talk about elimination. So elimination means that we are going to add to the left and to the right equivalent values. So on the left-hand side, I'm going to add x squared minus 3y squared. And on the right-hand side, I am adding the same thing, but it takes the form of a negative 12. And what's going to happen is that since my y squareds are additive inverses, they are going to essentially cancel each other out, and we will be left with no more y terms. So if I add these together, 2x squared plus x squared is 3x squared. 3y squared and negative 3y squared are inverses, leaving me with 3x squared equals 48. So x squared is 16, which means that x is either a positive or a negative 4. Now I need to find my y value, so I'll go ahead and plug these back in. I will plug them into what I think is the more simple of the two equations, and that would be the second. So my first that I'm going to plug in is an x value of positive 4. So 4 squared minus 3y squared equals negative 12. So 16 minus 3y squared equals a negative 12. Negative 3y squared is going to equal, when I subtract 16, I get a negative 28. So y squared is equal to negative 28 over negative 3, or 28 over 3. So y is equal to the positive or negative square root of 28 over 3. So when I plugged in a 4, I had two answers. The first was positive square root of 28 over 3, and the second was negative square root of 28 over 3. Now I plug in my -4. So if x is equal to a -4, -4 squared minus 3y squared is equal to -12. Well, -4 squared is 16. And that actually brings us to the same place that we had just a moment ago. Y squared is still equal to 28 over 3, which means that y is still equal to positive or negative square root of 28 over 3. So when I plugged in a -4, I had two results. I had positive square root of 28 over 3, and then I plugged in a -4, and I also got negative square root of 28 over 3. So in this case, we have 4 solutions, which means that our graphs cross in 4 different places. All right, go ahead and take a moment to pause the video and try this one out on your own. Here I do want to multiply my, let's say, first equation by a -1. So this will be a negative x squared, a positive y, and a -2. And then I have additive inverses, so I can add, giving me negative x squared, which doesn't combine with my 2x. So I also need to add 2x. When I add these two terms together, I get negative x squared plus 2x. Negative y and positive y are inverses, and that equals a -3. So then I'll add my 3 over to equal 0 so that I can factor. Step 1, I'll divide everything by a -1 so that I have a positive leading coefficient. And then I factor x minus 3, x plus 1 is equal to 0, giving me solutions of 3 and -1. So I go back and plug that in. If x is equal to 3, then 2 times 3 minus y equals -1. 6 minus y is -1, which means that y must equal 7. So my first solution is 3, 7. Now if x is equal to -1, then 2 times -1 minus y equals -1. -2 minus y is equal to -1, which means that y must equal a -1. So my second solution is -1, -1. So these two graphs cross at 2 points. The points are 3, 7, and -1, -1. All right, you've got one more to try. Go ahead and pause the video and try this one on your own. Here I'm going to go ahead and eliminate my x's, so I multiply my first equation by -5 and my second by a positive 3 to get those additive inverses. I then have the system of equations -15x squared minus 10y squared equals -130. And my second system is 15x squared plus 21y is equal to 9. So adding my x squareds or inverses, I have -10y squared plus 21y. So I must leave that as -10y squared plus 21y is equal to -121. And then I'll go ahead and add my 121 over so that I have equals to 0 on one side. From here, I need to factor if possible. If not, I'll use the quadratic formula to solve. I think we're going to have a bit of trouble factoring, so I'll go ahead and use my quadratic formula. So y is -21 plus or minus the square root of 21 squared minus 4 times -10 times 121 all over 2. And that simplifies to -21 plus or minus the square root of 5,281 all over 2. And now that we have our two solutions for y, we go back and we plug those in to find x. So 5x squared plus 7y equals 3. We replace my y with -21 plus rad 5281 over 2 and -21 minus rad 5182 over 2. I'm going to go ahead and stop here with this one and take a look at our last one, which I would like for you to go ahead and pause the video and try again on your own before I walk you through it. Elimination is going to look pretty tricky on this one because I don't have any matching terms. I've got powers of 2 in that second equation, but not in the first equation. So I'm actually going to go ahead and isolate my x and then plug that in for x in my second equation. So y squared minus 4 times the negative square root of y squared is equal to 12. And this one actually simplifies quite nicely for us to solve. From here we factor if possible, which this one is factorable, or use the quadratic formula if you're more comfortable there. you should have y is going to be equal to either positive 6 or negative 2, and from there we go back and we solve for x. That brings us to the end today. Thanks so much for watching.